All right, so for today's lesson, we are going to continue talking about how to solve quadratic equations. That is quadratic equations. That's supposed to be an A. Okay, so we talked last time about the fact that there are multiple ways to solve quadratic equations. We said we can factor. We can use the square root property. We can complete the square. And we can use the quadratic formula. In the previous video, we talked a little bit about using the square root property. Today, we're going to focus on how to complete the square. So that will be the subject of this video. All right, so let's say, for example, I want to solve a quadratic equation that looks like x squared plus 6x minus 7 equals 0. And those of you who are really comfortable with factoring might notice that this particular example here does factor. I can solve this equation by factoring and using the zero product property, but I don't want to do that. I want to show this, use this as an example to show completing the square. So that's what we're going to do. All right, so if I'm going to complete the square, the first thing I want is only the stuff with x's on it on one side. I'm going to move all of my plain numbers to the other side. So we're going to be looking at adding 7 to the other side, and we're going to get x squared plus 6x equals 7. Now, I know that a lot of my students have said that they are a little bit more visually motivated. So for this particular introduction, we're going to be looking at a visual and a more geometric understanding of completing the square. So we're going to take a look once again at just this piece right here, at just the x squared plus 6x piece. So, and we're going to look at it from a geometric perspective, from a visual perspective. We're going to talk about area. So x squared, if I were to think about x squared being an area, it would be the area of a square that is x by x. If you guys remember, the area of a square is side squared. So this square is x by x. So we have that. And then we also plus have this piece, this rectangle, that's 6 by x. So this length is x, same length as this length. And this length right here is going to be 6. And I want to make it clear, this is a plus sign. Okay, so we're adding the area of x squared to the area of this rectangle, which is 6 by x. Okay. And you can tell that when you have them next to each other, they don't, if I were to try to, for example, smush these two together, they would not look like a square. So here's what we're going to do. We still have this square that is x by x, And we're going to do something kind of counterintuitive here. I'm going to take this rectangle that's 6 by x, and I'm going to cut it in half. So I'm going to chop it in half right down the middle. If you guys can kind of pretend with me that that's right down the middle. All right, so I've now chopped this rectangle in half. This length is still x, right? The height of the rectangle didn't change. But now that I've chopped 6 in half, well, what's half of 6? Half of 6 is 3. So each of these small distances is 3. All right. So basically now, here's what we have. We have the square that's x by x, plus now we have two little rectangles. The height of the rectangle is x, and you want to call it width, I guess, I don't know. This distance here is 3, and I now have two of those. This distance is x, and this distance is 3. And again, if I smush this whole thing together, it's not going to look like a square. So hopefully what we've done is helpful, because it's not helpful just yet. Okay, so if you're okay with it, I'm going to take this square, I'm going to move it over here. So we have, here's the square that's x by x. And I'm going to pick up this piece that was x by 3, this first rectangle, and I'm going to grab it and I'm going to drag it over here. Drag it right there. So here's my little rectangle. You can see this distance is still x, and this distance is 3, so this is 3 by x. Okay, so I've dragged that rectangle. Cool. Now I'm going to drag the other rectangle over here. But before I do, I'm going to take it and I'm going to turn it sideways. So, I'm going to make some room, get rid of the arrows, but you know what we're doing is we're taking this, we're going to turn it on its side, and we're going to move it right here. All right. So this distance x is going to go right here. So this is still x. The height has now become kind of the length. And this distance 3 is now this distance 3. Okay, so you can kind of imagine now that I've moved each of these little rectangles, this one and this one, I've moved them here and here. And it kind of looks a little bit more like a square now, you can imagine. The only thing is it's not really a complete square, right? If you guys could pretend with me that I could sneak this little piece in and fill it in, then it would be a complete square, right? That's what we really want. Okay, so let's see what we can do to make that happen. Remember, we're still looking at trying to complete the square on x squared plus 6x equals 7. That's where this problem started. And now we've chopped up some of these pieces. I'm just going to keep this last piece right here for us. I'm going to get rid of this rest of this stuff to make some room. Okay. So we're looking exclusively now at this square right here, and what are the dimensions of this square? This new square that we completed, this square that's just a little bit too big. Well, it has this length right here. If you want to look at this length, is a length of x plus a little more, a length of 3. So this length is x plus 3. And the same thing here. This length is a distance of x plus a little bit more, a distance of 3. So this side also has x plus 3 as the length of the side. So our new square has dimensions. Our new square has the dimensions x plus 3 by x plus 3, which is x plus 3 squared. Right? So we've taken the original square, we've completed it, and we've made it just a little too big. So where originally we started with x squared plus 6x equals 7, we've now made the x squared plus 6x side bigger. And how much bigger did we make it? Remember, we made it bigger by adding in this little square right here. So I've now made it too big. Well, let's see. The dimensions of this square were, this length is 3, which makes this length 3. So the dimensions of the little square are 3 by, since this length is 3, that makes this length 3. So the dimensions of this new little square, the area, is 3 by 3, or 3 squared. Okay, so this new square is too big by an area of 3 squared. So since I added 3 squared to the left side of the equation, it's no problem. I'm just going to keep the right side of the equation equals 7, but also add 3 squared to the left side of the equation as well. So now what I'm looking at, where originally I was looking at the equation x squared plus 6x equals 7, now I'm looking at the equation x plus 3 squared equals 7 plus the area of the new little square, 3 squared. And if you're wondering, well, how am I supposed to do this geometric pattern for myself every single time? Just remember where the 3 came from. The 3 came from taking the rectangle. Remember, this 6x created this rectangle here, 6 by x. Then we took that rectangle and cut it in half. That's where the 3 came from. So in the future, if you want to think about it, you can go straight from this 6x, cut it in half, and get your 3. So that is how you complete the square. Now, this is a two-part lesson. This is teaching us first how to complete the square, and then second, how to solve the equation now that we have completed the square. So let's take a look at that. Let's get rid of the geometric stuff. And let's finish out the idea here, which is solving this quadratic equation. All right, so we've now officially completed the square, and we're going to move on to solve. First, I see I have x plus 3 squared. I'm not bothering to change that piece just yet because I still have 7 plus 3 squared. Well, 3 squared is 9. So I have x plus 3 quantity squared equals 16. And now I can solve this equation, now that I have it like this all nice. I can solve it using the square root property that we talked about in the last video. So how do I get rid of a square? Square root property tells me just get rid of a square by using a square root. I will take the square root of both sides. And in an equation, whenever I square root, if you guys remember, whenever I square root in an equation, I'm also going to plus or minus. Okay, so square and square root undo each other. I'm left with just x plus 3 on the left side. And on the right side, plus or minus, and the square root of 16 comes out nice. The square root of 16 is going to be 4. So we have this equation to solve now. Bring it up to the top. We have the equation to solve that x plus 3 equals plus or minus 4. Two possible solutions here. One, when x plus 3 equals positive 4, the plus version, and the other when x plus 3 equals negative 4, the minus version. So we have our plus and our minus. Okay, let's just make this look like an equal sign. Equals. Okay, so x plus 3 equals positive 4, and x plus 3 equals negative 4. I'm going to subtract 3. To get over here, x equals plus 4 minus 3 gives me 1. So one of my two solutions is x equals 1. For the other, subtract 3 from both sides to get that my other solution is x equals negative 7. So, but that's perfect because this is a quadratic equation. I know it can have up to 2 solutions, and here they are, my 2 solutions. X equals 1 and x equals negative 7. Those are my solutions, and so finally I will put them in set notation. And that is how you solve a quadratic equation solving a quadratic equation by completing the square.